Hello all. In this video we are going to look at finding the exact values for some trigonometric functions, so for sine, cos and tan, and how we can go about remembering them. There's a couple strategies. A lot of the time people just rote learn them. They just remember what it is. Sine of 30 is half. Sine of 45 is root 2 on 2, sine of 60 is root 3 on 2. Going to show you a couple strategies on how you can remember. One is a pattern, another one is using a hand trick, which you can see in this diagram here, which I'll make full size in a minute and go through that. So yeah, let's get cracking. The first way, so there's 5 angles we need to remember. We need to remember 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Now, for 0 and 90, you can always find those just thinking geometrically. Okay, think of unit circle, think of where your line is, what's the horizontal and vertical component, and that's why you can see that they are in the grey. Okay, there should be no reason you need to remember them, or if you do forget, you can find them geometrically using logic and reasoning. The other ones, 30, 45, and 60, one way to remember them is a pattern. Okay, and pretty much for sine and cos, you'll see here they're pretty much always of the form root something on 2. Okay, for the exact values you can remember they're root something on 2. Now that number that's going to be in the square root is either going to be 1, 2, or 3. Okay, and the advantage with square root of 1 is just 1, so that you can simplify it down to a half instead of square root of 1. So if we go back to the PowerPoint, okay, so the way you can think of it is if you think of sine, cos, tan, and this is the trick that they're showing here, is you think 1, 2, 3, 3, 2, 1. So these ones here are sine, and these ones here are cos. Okay. So starting from smallest angle to largest angle, that's telling you the numbers on top. Okay. So sine, the number on top is a 1, then a 2, then a 3, and as I said, the square root of 1 is just 1. Okay, so instead of square root 1 on 2, we can simplify that to half. So you just remember it's 1, then 2, then 3, then 3, then 2, then 1 for cos. Same thing, working from smallest to largest. So it goes up 1, 2, 3, 3, 2, 1. Tan is a matter of remembering 30 degrees is 1 on root 3. And then 45 is the numerator, and 60 degrees is the denominator. Okay. So this one is probably the most abstract in having to remember an actual value. All the others are something on 2. So that's the 1, 2, 3, 3, 2, 1 method. The other way is this hand method, which I really, really like. So I'm going to show you that now. Okay, so it's the left hand trick. So you put your left hand out, span it out so it looks like 90 degrees, and of course our fingers match up for the angles. 0 and 90, as I said, you can just have them there to think of geometrically. Okay, sine is the vertical component. So if I did sine of my thumb, well, how high up is that? Well, it's 0, so sine of 0 is 0. Okay. Otherwise, if I did sine of 90, okay, I fold that finger down. How high up is that finger? Well, it's all the way up, so that's going to be 1. Sine of 90 is 1. So you can do 0 and 90 with this, but this main trick is for these 3 here. So say you want to find cos of 30. Well, you bend your finger for 30 degrees, which makes sense. 30, 45, 60, that's roughly where those fingers lay out. So we bend that finger. Now cos is across, yeah? Cos is the horizontal component. So we count how many fingers it takes to go across to that one. So I need to go across 3. 1, 2, 3 fingers to get across to my knuckle. That means I put in here a 3. So cos of 30 is equal to root 3 on 2 because I had 3 fingers across. So what about sine of 30? What's sine of 30? Well, same thing, I keep my knuckle bent, bend my knuckle for 30, okay? Sine is what? Sine is up. Yeah, so how many fingers go up? To get to my knuckle, I need to go up 1 finger. So it's going to be root 1 on 2, which square root of 1 is 1, so it's equal to half. And we can do that for all the other ones. So cos of 45, bend my knuckle for 45. How many fingers do I have to go across? Cos of 45 is equal to root 2 on 2. Sine of 45. How many fingers do I need to go up to get to it? I have to go up 2. So I put that in my root. 2 on 2. So all I'm doing is how many fingers I have to go across or up. I'm putting in this square root. So sine of 60. Sine of 60, bend my knuckle for 60 degrees. How many fingers do I need to go up? I need to go up 3. So sine of 60 is equal to root 3 on 2. Cos of 60. How many fingers do I need to go across to get to it? I need to go across 1. That's equal to root 1 on 2, which is equal to half. Okay? So just by counting how many fingers you need to go up or how many fingers you need to go across, you can always find sine and cos. There is a really complex way of counting different fingers, including knuckles, to do tan shortcut, but tan, it's just easy to remember. The tan of 30 is 1 on root 3, tan of 45 is 1, tan of 60 is root 3. Okay, you just need to remember tan of 30 is 1 on root 3 and then break it down for the next 2. But that's how you can remember the exact values. So let's use some of these. So exercise 14F is a combination of using symmetry from 14E and then recalling these exact values to find solutions to trigonometric functions. Where these come from, we can show where these exact values come from by making these two triangles. If we make a triangle 45 degree, and they're both right angles, of course. Okay. If I make my two shorter sides both 1, which would happen with 45 degree, we can show that the hypotenuse is root 2. So we know sine is equal to opposite over hypotenuse, so that's going to be 1 on root 2. Cos of 45 is equal to adjacent on hypotenuse, so that's going to be 1 on root 2. And then tan of 45 is opposite on adjacent. So we get 1 on root 2 divided by 1 on root 2, which is just going to be equal to 1. And we can do the same for sine and cos. Okay, if we build a triangle that has 30 degrees, 60 degrees, and we make one side half and the hypotenuse 1, we can show, well, the adjacent side needs to be 1 squared minus half squared is 1 on the square root of 1 on 4, which is equal to 1 on root 2, which is also equal to root 2 on 2 if we rationalize the denominator. Okay, so sine of 30 is equal to opposite on hypotenuse, so we get half on 1 is equal to half. And sine of 60 is equal to opposite on hypotenuse, so we get root 2 on 2 on 1 is equal to root 2 on 2. we can keep this process going. Cos 30 is adjacent on hypotenuse, so we get root 2 on 2 divided by 1. Root 2 on 2. Cos of 60 is adjacent on hypotenuse, so we get half divided by 1 is equal to half. And then tan of 30 is opposite on hypotenuse, so we get half on root 2 on 2, so that's going to turn into the same as half times by 2, which isn't right. And 30 should be root 3 on 2. No, 1 on root 3. What mistake have I made? Hold on. This is equal to. There is an error in here. See, we make mistakes, but we always learn from them. That should be minus half squared, so we get square root 1 minus 1/4 is equal to square root 3/4 is equal to root 3 on 2. Okay. Yeah, that's right. Okay, sine of 30. Let's fix this up. Sine of 30 is equal to. I can get my brain to work now. Sine of 30, opposite over hypotenuse. 1 on 2. 1 is equal to half still. This is equal to 1 on 2. By 1 is equal to half. Sine of 60, opposite on hypotenuse, we get root 3 on 2. By 1 is equal to root 3 on 2. We get, and these can both be turned into root 2 on 2 over here, so I forgot about that to rationalize the denominator. Cos of 30 is adjacent on hypotenuse. Cos 30, root 3 on 2 divided by 1 is equal to root 3 on 2. So we have that, and now these will work out. So we get tan 30 is opposite on adjacent, so we get half divided by root 3 on 2 is equal to 1 on root 3, and tan of 60 will be root 3 on 2 divided by half, which will give us root 3. And there we go. So there's a proof where those exact values come from. Sorry about that mistake. I'll have to fix up those slides for next time. But a clear point to prove, just don't accept values when you get them if they don't match another source of information. So let's use those now. So evaluate sine of 30. Well, if you can't remember what it is, you can use your left hand. Sine of 30, how many fingers up? It's going to be 1 finger up. So we get root 1 on 2, which is equal to half. Cos of 45, middle finger, cos is across, a horizontal component, 2 fingers across, so that is equal to root 2 on 2. Tan of 60, okay, well we have, and this is where we do 30, 45, 60, we know this is get my brain to work, it is 1 on root 3, so that's 1, and that is root 3. You can always build a little table. Tan of 60, so that's going to be root 3. And another way to remember this is these will get bigger, okay? Bigger as the angle increases, which makes sense. Yeah, 1 on root 3, smallest 1, middle, and then root 3 is longer. So tan needs to get bigger as your angle increases up to 90 degrees. Okay, cos of 120. Well, what is cos of 120? We need to think that 120, which is there, is the same as going all the way around 180 and back 60. Okay, so this is that from exercise 14e where we look at symmetry within the unit circle. Okay, so that is going to equal to, now cos, it's in the second quadrant, cos, that'll be equal to negative cos of 60. Yeah, because in the second quadrant it's going to be negative value, and it's the equivalent of, cos it's the horizontal component. Okay, it's exactly the same as 60 degrees over here. So if you're not following that, you need to go back and look at 14e again. So cos of 60, cos, how many cross, that's half, so negative half. Tan of 225, so same thing, 225 is there. Okay, so that's the same as 180 plus 45. So in the third quadrant, that is exactly the same as tan of 45 because it is positive in the third quadrant. Tan of 45, we know there's 1. Sine of 240. Okay, 240, that's going to be 180. 180 plus 60, so there. And so in the third quadrant, that's going to be the same as negative sine of 60. So it is equal to sine of 60 up, that's negative root 3 on 2. Tan 7 pi on 4, okay, so that's the same as tan of pi plus 3 pi on 4, so that is going to be like that. Okay. Which we could also write that as the same as tan of 2 pi minus pi on 4. Okay, so that puts us in the fourth quadrant. That means tan is negative there, and then tan of pi on 4 is equivalent to. So pi on 4 is the same as 45 degrees, so it is going to be negative 1. Sine of 3 pi and 4, let's see if we can do this without a diagram. That is actually the same as sine as pi minus pi on 4. So that's going to put us in the second quadrant. So that is equivalent to positive, because sine is still positive in the second quadrant. of pi on 4 is equal to sine pi on 4 middle up to, that is root 2 on 2. Draw a little diagram. It's the same as going around pi, up pi on 4. Yeah, pi, and then back up pi on 4. Gets us to that point there. And cos 7 pi on 6 is equal to cos of pi plus pi on 6. So that is going to put us in the third quadrant. So that's the equivalent of negative, because cos is negative in the third quadrant. Negative cos of pi on 6. So that is equal to cos pi on 6 is the same as 30. Pardon me, sorry. 30 cos, how many fingers across is 3, so that's going to be root 3 on 2. Okay, so that's it for exercise 14F. Coming up with some way to remember all the exact values. You can just remember it by rote learning. Okay, you can remember that table if you want to. You can use the 1, 2, 3, 3, 2, 1 rule. You can use the hand trick here, left hand. Pretty handy because it also matches the first quadrant. With all of these, the first ones up here, okay, all of these, that was just in the first quadrant. All of these, they're breaking them down in terms of either going to the 180 or going all the way around to the 360 and then back as needed. Yeah? Okay, you're using the equivalents. You're always working off the x-axis. Okay, you can't break it down into a common mistake I see is this cos 120. The wrong way to do it would be people will say that's the same as cos 90 plus 30. So they'll then think, oh, that's going to equal to negative cos 30, which isn't true. Okay, because while it is 30 degrees around there, this equivalence does not work. Okay, you have to work off the axis because that's where we're working our horizontal and vertical components. If you have any questions, let me know. Ask in class as usual. But I hope this helps. Thanks. See ya.